Friends, hello and welcome to my YouTube channel Tech Guru Speaks. Today I would like to describe one of the important classes of the Java collections framework, and it's called the linked list class. Basically, java.util.linkedList class is the doubly linked list implementation of the list and DQ interfaces. As you already know, the parent of all the classes and interfaces in the collection framework is the java.util.collection interface. Now from collection we are basically getting three sub interfaces like set, list and queue. Now dq is basically a sub interface of queue interface. So in that sense we can say that linked list will have the properties of list and queue both. This class provides all optional list operations and permits all elements including null. So this is not supported by array list, mind it, but it is being supported by linked list. It can also include null values. So it is not being supported by the array list class. As the class, I mean to say as the linked list class implements queue, more methods are available than array list and vector, such as offer, pick and poll, etc. So these methods are basically obtained from the queue interfaces. So since ArrayList is basically uh, the dynamic array implementation of the list interface, linked list is basically getting all the features from list and queue both. So it must have more methods available for the developers. So that is the basic idea. Now if we see the signature, it is like that: public class linked list, it supports the generics concept, extends abstract sequential list, implements list, DQ, clonable and serializable. Now for the array list, if we are going to compare between linked list and array list, we can find that array list is basically the resizable array implementation of the list interface. Obviously it is denoting a dynamic array. So it is like public class array list, extends abstract list, implements list, so it is common. DQ is there in the linked list, but it is not having DQ support. I mean to say there is no support of queue in the array list. It can have random access, clonable and serializable. So because of the presence of this interface random access, we could be able to access the elements of the array list by their corresponding index value. So that will make the searching operation faster compared to linked list. So but clonable and serializable, these parts are common. So list, clonable and serializable, these parts are common basically with respect to the super interfaces from which linked list and array list are being created. But the thing is that linked list extends abstract sequential list, but array list extends abstract list and it implements list only, but it implements list and DQ both. So in that sense, apart from clonable and serializable, so since it will be uh, created from the list and DQ, so it will be having the features of list and queue both. So that is why we are getting more methods compared to the array list. So that is the basic idea about the linked list class. Now we are going to compare between array list and linked list. Array list is best choice if our frequent operation is retrieval operation. So by using get and set method, we could be able to perform this retrieval operation. So that is the basic idea. Since if I go back to the previous slide, you could see that array list is having random access. So because of which accessing the elements will be faster. So array list is the best choice if the frequent operation to be performed is the retrieval operation. Okay, so for linked list it is the best choice if our frequent operation is insertion and deletion in the middle. Okay, that means middle of the linked list. So that is point number 1. So obviously array list must be the worst choice if the operation is insertion and deletion in the middle, because internally it requires several shift operations to be performed. So insertion and deletions in the middle will be easier to perform in linked list, but it will be difficult to perform in the array list because of several shift operations to be performed. But obviously for the linked list it will be the worst choice if the frequent operation is retrieval operation, because it is not having any support like random access which is supported in array list. So for array list retrieval operation will be faster, but for linked list it will be slower. So now we can get the advantages and disadvantages of array list and linked list. So for array list retrieval operation will be faster, but for linked list it will be slower. For array list insertion and deletion of elements at the middle of the list will be slower because we need to perform some shift operations. But in the linked list, say adding or deleting elements in the middle of the list is faster. So linked list will be the best choice for that particular set of operations. So that is point number 1 and point number 2. Now the last point, that is about array list. It says that in array list elements will be stored in consecutive memory locations, because this is the implementation of the say dynamic array. Okay, so generic dynamic array, that means the resizable dynamic array. Okay, and hence retrieval operations will become easy. Okay, so that is the feature of the array list. So the elements are going to be stored in the consecutive memory locations, that means adjacent memory locations. In linked list the elements are not stored in the consecutive, that means adjacent memory locations, and therefore the retrieval operation will be complex. So that is the idea. So this is the difference that may exist between the array list and the linked list. Now we are going to see the demonstration of the linked list class, say in terms of the program development. And in order to develop this program in Java, I will need the say Apache NetBeans IDE 12.1. Since NetBeans is one of the most popular IDEs for program development, I will be using that particular IDE for program demonstration in the video tutorial series for Java. So now I will be creating a class. So it is called say linked list demo. So linked list demo is the class name. So it is just created. It will be creating the structure, initial structure. So now I'll be doing what? I'll be including the main method here so that I can write statements inside it. So now I'll be trying to create a linked list object. So linked list that you can see here. So linked list. So basically if I write here linked list, since it is not imported, so it will be asking for it. So now I am importing this like java.util.linklist. So suppose I am going to create a linked list object of integers. Okay, so that is the so now I will be creating the object here. So now the object is created. So I would like to add some elements onto the linked list. Say first element will be 11, second element will be 22, third will be 44, sorry 33, and the fourth one will be 44. So 4 elements are added one by one, so all of them will be appended basically. So now I would like to show you the present status of the linked list. So it will be now shown to you while I'll be trying to run the program for the first time. It will be shown. So it is the present status of the linked list. At the same time, I would like to show you its size. So the size of the linked list, that means how many elements are there, it will also be shown. So this is the method size. Okay, so returns the number of elements in the list. So if I run this program, you could see the present status, that means present status in terms of its configuration. So it will be showing, so it is having 4 elements, 11, 22, 33 and 44. So it is having the size 4. So now I'll be using the iterator interface to iterate through the elements of the linked list. So using iterator interface to iterate through the elements of linked list. So that is my objective here. So now I'll be iterator is the interface name. So it is added here. So now I'll be trying to create a iterator here. So by calling this method called iterator, so it will be done here. So now the linked list elements will be shown here. So linked list elements will be shown here one by one by using, say for example, a while loop. So it dot has next, it will check if there are any elements in the iterator or not. So then comes s out, so it will be added after the loop. So I am going to use here system.out.print. So the method that will be called here is called next. So that will give you the current element of the linked list, which is stored in the iterator actually. So now if I am going to run this program, so it will show you that you could be able to access the elements of the linked list by using the iterator. So I have already used this thing with respect to array list and vector as well, that you can understand. So now I am going to use some different methods with respect to the linked list object, that is called list here. There is a reference actually. So now I am going to check here the list is empty or not. So check list is empty or not. Okay, so for that reason I can use here the method called, so first I'll be writing here list is empty or not. So I can call this method dot list dot, so this method is called is empty. So it is basically will return a boolean type variable, so either true or false, that will be the outcome. So better to write this in question form. So now I am going to run the program once more. So it will show you the status. So it is false, so that means the link list is basically non-empty, it is not empty. So it is actually non-empty, so that is why the value is false actually. So now I am going to use here methods like, say, at first. So now I will be adding here this particular element 55 here. I can also so add at the beginning, or adding at the first location. So it will show you the current status after applying these two methods on the list, which is basically the object reference of the linked list class. So 55 added at the beginning, that is the first location, and 66 basically added at the last. So that is the idea that you can see here. So now suppose I would like to add this element 99 by using this method add, but using the second overloaded version of the add method. Suppose now I would like to add 99 at the second position. So that is my objective here. So in order to do it, I'll be using the second overloaded version of the add method. So then I'll be using the same set of SOPs here, so which will show you the present status of the linked list as well as the size. So that you can see here. So at the second position 99 has been added by calling this method here, that you can easily understand. Now suppose I would like to, say for example, add another method, say list dot, say this one I would like to add here. Say for example I would like to add, so just I would like to show you one thing before actually calling this method. So it is basically called the offer method that we have already tested with respect to queue example, like by using the array dq example. That was also actually done. So now I am actually going to use this thing. So suppose I am going to add here, say for example 101. Okay, so that will be done now. As I have told it before, since it is coming from list and dq both, it will have more method support compared to array list and vector that I have tried to show you. So this is basically coming from this queue family. Now I am going to show you several methods like get first or get last to show you the first element and the last element in this particular linked list. So first element can be obtained by calling the method, so get first, so that is the method name. Similarly, I can have get last as well, which will give you the last element of the list. So you can see it here, get last is used here in this program. So it will be showing you the first element that you can see. So it is the present status of the linked list object denoted by this reference list. So 55 is the first element and 101 is the last element. So that is shown here. I can also access here any specific data. So by using the get method, say element at position 3 that I would like to retrieve. So that is my objective. So in order to do that, I will be using here the list.get, this particular method. So suppose 3 will be the value of the index position, so it will be showing you that particular value also. So you can see that, so 0 1 2 3, so it is basically 22. Okay, so I can also write here this particular statement. So however the result will be the same. So this is basically 22. So now I would like to remove the first element. So these are basically addition operations. So all these are basically, say, addition operations that we have performed till now. Add method. So this is the second overloaded version of the add method. Add first, add last, offer method. So all these are basically addition operations. Then I have performed here some kind of retrieval operation like get first, get last, or get method. So that will give you the retrieval operation. So I can do here one more thing. Say for example, suppose list dot, if I am writing here the method pick, so it will retrieve but doesn't remove the head of the list. So that I can also use here. So it is basically the first element, I would like to say. So that can also be used here. So I have used offer, pick, which are basically coming from the queue family. So it is showing here the front element. Okay, so you can also write here the front element, same thing, first element and front end, that is the same thing according to this particular concept. So now I would like to use here, say, method like remove first and remove last, because now I would like to perform the removal operation. So now I'll be using here method like remove first. So that is the method that I am going to apply here. So now I would like to show you the current status and the size also. So it was having the size 8. Now the front element gets deleted. So now 11 will become the front element, that you can see. So I have already told you 55 is the front element according to this particular configuration of the linked list. So now if I call this method remove first, it will be now removing the front element from this particular linked list. So now it will be giving you the current status of this linked list as follows. So that is the idea. Now I am going to use here remove last. That is the method that I can use here now. So remove last is the method that I am going to use here. So that now you can see it here. So it will be actually removing the last element. So 101 gets deleted here. So the size will also be decreased. Earlier it was 8. Now after applying the remove first operation, it will become 7. Now after applying remove last operation, it will become 6. Now I am trying to perform removal operation in terms of the remove method. Suppose by specifying index, suppose I would like to delete the element at say index position 1. Now I am going to use the same set of SOPs here to show the present status and the size of the linked list. So now you can see that 92 gets deleted here. Okay, so that is the idea. So I can also use the poll method here, which is also obtained from the family, that is the queue family. So now I am going to use it, say poll. So item removed, and now I'm going to use the same set of SOPs to show you the present status of the linked list. So I can also ignore this. So earlier it was having 5 elements, 11, 22, 33, 44 and 66. Now the front element gets removed. That means the item which is removed here is 11, that you can see here. By calling the poll method, actually it will be doing the removal operation. It will be actually removing the first element, which is the front element actually. So now it is having 4 elements. Okay, so this is the present status of the linked list and size is 4. Now I am calling the clear method, so it will clear all the elements in the linked list. So now I will be using this method to check whether this list is empty or not. So before using it, I can also show you the present status and the size of the linked list as well. So This is the last set of operations that I am performing here for this particular demo program. So linked list, it will be showing the present status of the linked list. It is not having any element, so the size is 0. So is list empty or not? It is true. That means the linked list is not having any more element here. So that is the idea of using this particular method called isEmpty. So I hope that you have understood the basic operations of the linked list class in terms of the object creation. I have created here a linked list object of integers. Now after creating the object, I have performed different kinds of operations like addition operations by using add method. Two overloaded versions of adds are being used. Now I have used add first, add last, offer method. Then I have performed the different kind of retrieval operation like get first, get last, get pick. So it will pick the front element. Then I have tried to perform some removal operation like remove first, remove last, remove by using the index method. So there are different kinds of overloaded version of remove method is available that I have already shown. So now I have tried to use the poll method, which will actually remove the front element. So because I have already told you, it will be actually the linked list will be getting all the features from the array list as well as from the DQ. So it will be having more method support compared to array list and vector. So that is the set of operations I have performed in terms of linked list object. I hope that you have understood the basic logic of this program. So if you like this video, then I'll be requesting you to subscribe to my YouTube channel. So this is the URL of my YouTube channel. So actually I need your support to uh, get some kind of encouragement, and also it will give me a chance to grow. So if I can grow, then I could be able to create more useful videos for you which will be beneficial for you in terms of career development. So this is my website, techguruspeaks.com. You will get lots of useful information on different technologies of information technology. So you can visit this website. So this is my email, admin@techguruspeaks.com. So you can use this email to contact with me. So I hope that you have understood the basic operations of linked list after watching this video. So have a nice day. Thank you very much for watching this video. Thank you.